Welcome to class 11th and class 12th math lessons. Today we will learn the trigonometry functions or trigonometry. This is unit 3 of NCERT book. Before starting this, if you want to brush up your trigonometry knowledge, then go through my video, 10th class maths videos. Okay, there is a trigonometry video there. You can go through that and solve those basic problems of trigonometry and the trigonometry applications there. Then come to this one. Uh, this is mainly meant for class 11th and class 12th and engineering entrance exams. What we are going to cover in this is uh, all the NCERT book chapters, okay, lesson, complete trigonometry function lessons, and then critical problems from the JEE. Okay, so trigonometry is very critical actually for class 11th, class 12th, and engineering entrance exams, mainly because trigonometry may not be asked straightforward questions actually. It will combine with quadratic equations, functions, sets, differentiation, integration, geometry. Everywhere trigonometry will be combined, and you will be asked a question about those concepts actually. And the trigonometry, they assume that it is the basic underlying knowledge. Okay, so it is so important. It is just like sets, relations, and functions. That this basic knowledge you should have to solve any of these math problems. Okay, so what we are going to cover is basic angles, trigonometric ratios, not ratios, that is ratios, trigonometric functions, and the combinations of angles and trigonometric ratios. Okay, like what is the sine a plus b, cos a plus b, then sine a plus sine b. Okay, those kind of things. Okay, then all the NCERT exercises we will cover, and in the end, I will have at least some questions from JEE, mostly all the critical questions from JEE which were asked actually. I will cover at least 5 to 10 of those in this video. And after that, I will make anyway charts for easy JEE and BITSAT questions and other entrance exam questions. I will make charts, easy questions, and all the critical questions, complex questions, I will make videos again, okay, for the trigonometry problems. So this is the beginning. Okay, let's get into the trigonometry functions. Okay, first thing you have to learn is just brush up your knowledge on the angles. Okay, so angle is defined like this, right? You will measure it angle like this. Okay, and angle is always measured in clockwise. Sorry, anti-clockwise. Okay, so or counterclockwise we say. Okay, so angle is always measured like this. Okay, theta is from angle from this base to the target line. Okay, terminal line. Okay, and if you are measuring the angle in a clockwise direction, then it is negative. Okay, you should represent it as a negative angle. Okay, that's the only difference. If it is positive angle, it is measured in counterclockwise. Okay, and then radian and degree are the two units of angle. Okay, uh, pi radians is equal to 180 degrees. This is the radians and angles equality. Okay, and how do you define radian? Radian is nothing but if you have an arc of L, arc of length L, and the radius r, then number of radians equal to theta equal to L by r. Okay, which means radian definition is if the arc length is equal to the radius, arc length is equal to the radius, the angle subtended by those two radius is 1 radian, right? So theta equal to L by r, and we know 2 pi radians is 360 degrees, or pi equal to 180. You can take whichever you want for all the conversions from radians into degrees. Okay, and the degrees are further divided into minutes. So 1 degree is 60 minutes, denoted as 60 dash. Okay, and 1 minute is equal to 60 seconds, which is denoted as 60 double dash. Okay, you can call double dash or double quotes. Okay, 60 seconds it is. Okay, these are the basics of the angles. Okay, let's get into the basic questions on these angles actually from the NCERT exercise 3.1. I will not go through that all the questions. Okay, only the first and just important questions. Okay. Okay, first one is convert these radian measures corresponding to the following. Find the radian measures corresponding to the following degree measures. Okay, 25 degrees is given. So how do you convert? This is a simple unitary method which you learn in third or fourth class, right? Pi radians is equal to 180 degrees. So 25 degrees is how much? Okay, you say 25 by 180 into pi, which is that's what I'm doing, which is nothing but 5 pi by 36. I can leave it like this, or you can take pi value as 22 by 7 and then put the value. That's also fine. Okay, so it's a simple unitary method. And this is how you have to do. And another thing is if degrees are given in degrees and minutes, first convert everything into one unit, that is degrees. So like minus 47 degrees 30 minutes. This is nothing but minus 47 plus half, okay, which is equal to, you have to do this way, right? So 95, 95 by 2, this is nothing but, okay, so minus 95 by 2 into pi by 180, which is minus 19 pi by 72. So this is the way you will convert radians into degrees or degrees into radians. Okay, same thing. Again, here radians are given and you have to convert into degrees. Okay, so whenever you convert into degrees, let's say 11 by 16 is the radians given. So 11 by 16 into 180 by pi. Again, you apply unitary method here, simple. So what you got is 39.379 degrees. Okay, so don't leave degrees in decimal. Okay, this is nothing but 39 degrees plus 3.75 or 0.375 minutes into 60 minutes. Okay, right? So which is equal to 39 degrees, 22.5 minutes. Again, minutes also don't leave in decimals. Okay, zero point 0.5 minute is, we know that it is 30 seconds. Okay, so the ultimate value is 36 degrees, 22 minutes, 30 seconds. So this is how you should convert radians into degrees. So when you convert into degrees, please make sure that you don't leave it in decimals. You should convert into minutes and seconds. Okay. So these are the other problems which you can go through it. Okay, you can pause the video and first you solve it yourself, then cross check by checking these videos. Okay. Okay. Next. So this is another question. In a circle of diameter 40 centimeters, length of a card is 20 centimeters. Find the length of minor arc of the card. Minor arc is nothing but BC measured like this. Okay. So to measure this one, what you need to know? You need to know theta in radians. Once you know theta in radians, you know what is the radius. Radius is given as 20 centimeters because diameter is 40. So radius is 20 centimeters. You just need to measure this arc, right? That's it. Okay. So card is given. The card is 20 centimeters here. BC card is 20 centimeters. You need to find this arc. Okay. How do you find it? Radius of circle is equal to uh, 40 by 2. Why it is 40 by 2? Radius of circle diameter is given as 40, so 40 by 2, which is 20. So ABC is a equilateral triangle. ABC is a equilateral triangle. So BC is 20. So AB also radius, which is 20. Okay, and AC also radius, which is 20. So all three are same side. So it's a equilateral triangle. So we know equilateral triangle angle is 60 degrees. So theta is equal to pi by 3. Right. Once you know angle in radians, the arc is equal to 20.1 centimeters. Okay, you'll substitute, right? Angle equal to L by R. So that's what I did. Okay, yeah. Next, yeah, you can try solving yourself these problems. Okay, all these you can try solving yourself. Okay, let's learn the definitions of trigonometric ratios. You already know from class 10th. Okay, these are all same exactly. We just brush up the concepts, basic concepts. Okay, so if you take a right angle triangle and you define an angle at one of the side basically as theta, then other one will be 90 minus theta, we know it. Okay. Now from this angle point of view, all trigonometric ratios are defined, okay, with respect to three sides. What is that? Adjacent, which is attached to the angle, opposite, which is opposite to the angle, and hypotenuse. Okay. So the definitions are sine theta is opposite by hypotenuse, cosine theta or cos theta is adjacent by hypotenuse, tan theta is opposite by adjacent. Okay. Cotan or cot theta is 1 by tan theta, okay, which is adjacent by opposite. Okay, secant theta or 1 by cos theta, which is equal to hypotenuse by adjacent. Okay, cosecant or cosec theta equal to 1 by sin theta. Okay, which is nothing but hypotenuse by opposite. Okay, these are the basic definitions. Out of this also, actually top three are the main definitions. Other one are just reciprocals, if you see. Okay, so these are the three definitions. So any formula with respect to these three, if you remember, then you can easily apply it to other things also. Okay. There is nothing special you have to remember or learn. Okay, by practice they will come. I mean, you will remember them easily. Okay, and one more thing is these ratios are constant for the given angle. Okay, if the angle is 30 degrees, sin theta is always 1 by 2. Okay, so the opposite and hypotenuse will align in that ratio. Okay, so that is what you need to understand. This is the relation between angles and sides of a triangle. Okay, so once you know this, you need to remember some of the important angles. Okay, this is what the table you will learn from your class 10th. Okay, you may add a few more angles here, and then you should know how to derive for the other angles. Okay, something like for 15 degrees, 18 degrees, 36 degrees, those things you should remember for a quick calculation. And how do you remember so many things? It's very easy. You have to just practice, 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 then it will be there in your mind. Those numbers will remain in your mind. Okay. So this is the table which will define sine of 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. These are the values. Cosine values for each of these angles, tan, cot, secant, cosecant. Okay. Now, what is this not defined here? Okay. So whenever tan theta is 0, okay, cot theta is 1 by tan theta. So 1 by 0, which is not defined. Okay. Similarly here. Okay. Sorry. Similarly here, tan theta, tan 90 is not defined because it is 1 by 0. Sine by cos. Okay. So this is what you should remember. An easy way to remember is for the initial practice, but I don't want to you to just remember this method actually. You should remember the values. Okay. The method is simple. If you calculate for sine theta, for cos theta, these values are exactly in reverse order. Okay. Tan theta is sine theta by cos theta. You can calculate. Cot theta is 1 by tan theta. Secant theta is 1 by cos theta. Cosecant is 1 by sine theta. So all these values you can write. Only thing you should know is sine theta values. That's it. Okay. How do you make sure that you get correct values for sine theta? Okay. You write 0, 30, 45, 60, 90. Give them a number 0, 1, 2, 3, 4. Okay. Divided all of them divided by 4. 0 by 4, 1 by 4, 2 by 4, 3 by 4, and 4 by 4. Square root them. Okay. 0, 1 by 2, 1 by root 2, root 3 by 2, and 1. These are the values of sine theta. And cos will be, you can compare with this. Okay. Same values. Cos will be exactly reverse order. Then tan, cot, secant, cosecant, all you can derive. Okay. So this is one method of remembering. Other method, a lot of people also practice using hand. Very easy actually. You take your hand, left hand like this. Okay. You put 0, 30, 45, 60, and 90. Okay. Now sine theta is, I'll just give an example for sine theta. You can remember only for sine theta. Others you don't require to remember actually. Right. Sine theta is square root of bottom fingers. Okay. If you take sine 0, bottom there is nothing. So 0, 0 by 2 is 0. So sine 0 is 0. Sine 60, let's say. Sine 60 is bottom is 3. Okay. Sorry, bottom fingers are 3. And that's it by 2, right? So square root of 3 by 2, sine 60. So this is how you will, you can easily look at the finger and tell the values of these trigonometric ratios. Okay. If you want to just little bit more easy to remember is cos theta will be top fingers by 2 instead of bottom fingers. Let's take cos 60. Cos 60 is one top finger, only one is there, right? 1 by 2. Okay. Square root of 1 by 2, which is 1 by 2. So cos 60 is 1 by 2, like this. Okay. Tan also sine by cos, so you can easily guess it, right? So this is the trick to remember these values. And then you should know sine theta cos theta is not only for 0 to 90 degrees. Okay. It is for any angle. Then how do we remember these things? Okay. This is very, very important. Okay. So in first quadrant, okay, in first quadrant, all the trigonometric ratios are positive. Okay. And in the second quadrant, sine and cosec are positive. Okay. In third quadrant, tan and cot are positive. Fourth quadrant, cos and secant are positive. So the people elders made some trick to remember this one. Easy way to remember all are positive. Silver T cups. Silver you take S. S is sine and cosec. Okay, these two are uh, reciprocals, right? Sine and cosec. Then T stands for tan. So tan and cot reciprocal. Cups C stands for cos and secant reciprocals. Okay, so this way you can remember them easily. And how somebody has defined that these angles are negative, positive in this quadrant, rest all are negative. It is very easy to understand actually. If you take first quadrant, okay, first quadrant, if I draw a right angle triangle here and call this as theta, angle theta, okay. Now what is sine theta? Sine theta is opposite by hypotenuse. Opposite is in positive side of x-axis, correct? Hypotenuse is always positive anyway, okay. So this is positive by positive, which is positive, okay. Tan theta, if you take positive by positive, okay, opposite by adjacent, positive by positive, right? Similarly, you go to second quadrant. In second quadrant, angle will shift here, right? If I rotate this triangle this side, this is where angle comes, right? Now sine theta is what? Sine theta is positive y-axis, correct? So positive length divided by hypotenuse, which is positive. Okay. What about cos theta? Cos theta is negative length here, right? Negative side of the x-axis. So this is minus value. So negative by positive, hypotenuse, right? Adjacent by hypotenuse. So negative by positive, which is negative. So cos theta is negative in second quadrant. Okay. Similarly, cosec theta, if you take hypotenuse by opposite, which is positive, and the tan and cot will be negative in this. Similarly, other two quadrants. So this is what how they defined the each trigonometric ratio, positive or negative, in the given quadrant. Okay, all four quadrants. Okay, next. Okay. So what is the meaning of this one? If I take sine 120 degrees, okay, sine 120 degrees is 120 is in which quadrant? Second quadrant, which is sine 180 minus 60. You will know how to get this sine 180 minus 60 in the next slides. Okay, which is nothing but sine 60, because sine 60 is positive here. Okay, and tan 310. If you take tan 310, 310 belongs to fourth quadrant. Here only cos and secant are positive. Tan is negative. So tan will be 360 minus 50, okay, which is nothing but fourth quadrant, and which is tan of minus tan of 50. Okay, so this is the how you utilize this trigonometric angles in each quadrant. Okay, most important thing is you have to decide this complete angle is in which quadrant. Then you put the sign plus or minus. Okay, and these are all the trigonometric ratios which you should remember. Okay, and such a big table, how to remember? Is it easy? Not easy? This is very easy actually. Once you know your all silver teacups, actually, this four quadrant which are positive and negative, it is very easy to tell. Okay, and I will also tell you about this 90 degrees, how to trigonometric ratio of using complementary angles. I'll tell you that shortly. But meanwhile, let's take sine of, let's take 270 minus 360 minus theta. Okay, sine of 360 minus theta is 360 minus theta goes to fourth quadrant. Here sine is negative, so it is minus sine theta. Okay, let's take cotangent or cot theta of 180 plus theta. Okay, 180 plus theta is 180 plus theta is here, belongs to third quadrant. So in third quadrant, cot is positive. So cot of 180 plus theta is cot theta. Okay, and why it should be cot theta, why not tan theta, I will tell you shortly. Okay, when it will become, see, if you take cotangent of 270 minus theta is tan theta. Okay, whereas cot of 180 plus theta is cot theta. Why it is cot theta here, why it is tan theta here, I will tell you shortly. But you look at the angle and sine. Okay, angle and sine. 270 minus theta also belongs to third quadrant. That's why cot is positive here. Now, when it will change the complementary angles, okay, tan and cot are complementary angles, correct? Sine and cosine are complementary angles. Okay, sine theta equal to cos of 90 minus theta. Tan theta equal to cot of 90 minus theta. Secant theta equal to cosecant of 90 minus theta. Right? So they are complementary angles. When the complementary ratio should be applied, if the angle is even integer multiplied by pi by 2 plus or minus theta, then function remains same. Trigonometric function, I mean to say. Okay, which means, example, sine pi minus x. Pi minus x, I can write it as 2 into pi by 2. Pi by 2 is 90, right? 2 into pi by 2. So it is even integer multiplied by pi by 2 minus x. So what I am trying to tell you, function remains same. So sine will be sine only. It is sine x. And why it is x? The sine is based on the quadrant. Pi minus x is second quadrant. Pi minus x is here, right? Belongs to here. Here sign is positive. So it is plus sin x. Okay. So if you see here, sine of pi minus theta is sin theta. Okay. Similarly, if angle is odd multiple of pi by 2 plus or minus theta, then function becomes complementary, which means, example, sine will become cos, tan will become cot, secant becomes cosecant. To and fro. Cos 90 plus x. Cos 90 plus x belongs to second quadrant because it is 90, which means 1. 1 into pi by 2, right? 1 is a odd number. So, because it is odd, cos will become complementary ratio, which is sin x. And since the 90 plus x angle belongs to second quadrant, where cos theta is negative, the source cos theta is negative, right? So, it is minus sin x. So, this is how you should uh, do these things. Okay. So, if you see here, cos 90 plus theta is minus sin theta. Okay. And other than all this, one more extra thing we have is sine of minus theta, cos of minus theta, and all this, right? So here if you see, only cos theta and secant theta are positive. Rest all sine of minus theta is minus sin theta, tan of minus theta is minus tan theta, secant of minus theta is uh, cosecant of minus theta is minus cosecant theta. Only cos and secant are positive. Why? Sine of minus theta is always means you are calculating in the anti-clockwise direction, right? Angle is in the anti-clockwise direction. So where it belongs to? It goes to fourth quadrant. Angle will be here. Anti-clockwise. Sorry, clockwise. I have to measure clockwise. Minus theta is clockwise measurement. So angle comes into fourth quadrant, right? Below 360 degrees. Fourth quadrant. In fourth quadrant only cosine and secant are positive. Rest all are negative. Okay. So this is how you should remember all these things. It's a big chart, looks very big. How to remember? Very simple. This is what you should remember. Okay. And calculate very quickly. You practice more, you will be quicker. Okay. And the most important formula of trigonometry is this one: sin square plus cos square theta equal to sin square x plus cos square x equal to 1. Okay. We can derive two other sin squares based on this one. One is 1 plus cot square theta equal to cosecant square theta. Okay. Or cosecant square x minus cot square x equal to 1. Okay. Basically, if I divide with sin square theta, that's what I get. Okay. 1 cot square x equal to cos x square x, right? And the same equation, if I divide with cos square theta, I'll get tan square x plus 1 equal to secant square x, which implies secant square x minus tan square x equal to 1. Okay. So remember, these are the basic trigonometric formulae. Uh, and most of the things are derived from this one. Okay. So this is very, very important. You can apply everything, convert into sine and cos, and you can apply this equation. Or better way is, if you want to do things faster, you should remember these things also. Very easy. You just divide the main equation, right? With sine or cos, it's what you will get. Okay. Let's do NCERT exercise 3.2. I'll not go through all the problems. Just I will explain few of them, important things. Okay. One of the typical question which comes is, you will be given one of the trigonometric ratio and find the other things, right? So cos x equal to minus 1 by 2. So you need to know relation with one trigonometric ratio with the others. Okay, cos x is minus 1 by 2, secant is minus 2. Hence, and you can apply this cos square plus sin square x equal to 1. From that you will get sine value. Okay, and then from that you can get cosecant, tan x, cot x, everything. Okay, so this is one way, because here, okay, when once you get sin x values plus or minus root 3 by 2, you have to decide, because it is given that x is in third quadrant. Third quadrant sign is negative. Okay, that's why I took only minus root 3 by 2. Okay, so these things you should take care. Other way of doing is, you build a right angle triangle. Okay, given information is cos x. Okay, cos is adjacent by hypotenuse, so 1 by 2. You can always calculate the opposite using Pythagoras or Bodhayana theorem, right? So once you get it, only thing is, you can put all the trigonometric ratios, but make sure that the sign is correct. The sign comes from all silver teacups, if you remember. Okay, right? All silver teacups. Remember the sentence, and then based on that, you decide what is the value of sine is in the third quadrant, sine is negative, tan is positive, cot is positive. Okay, cosecant is negative, secant is negative. This is how you should do. Okay, so all the problems are almost similar. You can do it yourself. Okay, at any point you can first try it yourself, pause it, and cross check the answer. Okay, you can try whichever way you want. Uh, you can draw a right angle triangle and do this also. Okay, and these are you basically apply that rule I mentioned. Odd integer into pi by 2 plus x, and odd integer into pi by 2, even integer into pi by 2 plus x or minus x. Okay, that rule you can apply. And you know that 360 degrees, when it is 360 degrees, more than 360 degrees, you can straightforward remove all 360s. Multiples of 360 you can remove directly. Okay, so here that's what I did. When it is 360 degrees, the angle is coming back to the same position, right? So I'm removing the multiples of 360 first from the angle, and then remaining I'm seeing. Okay, so you can try whatever way. I have already given you the formula for this one, how you will get minus plus. Okay, right? So this negative minus or plus is purely based on your angle here. Okay, okay, try it yourself. All these problems, these are very basics. You should do it so that you can solve the other critical problems. Okay, now let's learn the trigonometry formula for compound angles. What are compound angles? Something like cos A plus B, okay, is how much? Okay, you know that, let's say you want to build cos 75 degrees. How do you do cos 75 degrees? Okay, cos 75 is nothing but cos 45 plus 45 plus 30, right? So cos of 45 plus 30, that is given, the equation is cos A cos B minus sin A sin B. Okay, so this is the form equation which you should remember. Okay, it is very. I'll just give the proof for only this one, but other things you can try it yourself. Okay, so let's take a circle of unit radius. This is the circle of unit radius. Center is at 0, comma 0. Okay, so obviously this one is, because it's a unit radius, it will be 1, comma 0. Correct. Now you take an angle A, you draw a radius. Okay, what will be these coordinates? What will be the coordinates at this point? Okay, you draw a right angle, a perpendicular line. Okay, then this is angle A. Okay, and what will be this value? This height will be, this height is opposite by hypotenuse is sin A, right? So this height is sin A. Y value is sin A. And what is the x value? This is the x value. This is the adjacent. Correct? Adjacent is nothing but cos A into 1, because this radius is 1, right? Okay. So these coordinates are cos A and sin A. Similarly, I draw another line of unit radius, okay, at angle of B from this line. Okay. Total angle is A plus B, but this is B angle, angle B. Okay. So what is the coordinates of this one? Obviously, this is A plus B. So this value will be cos A plus B, comma sin A plus B. Same way as we did here. Okay, you can do it. Now I draw another angle minus B here, because anti-clockwise, this is clockwise direction. Okay. What will be the values of this one? This is in fourth quadrant. Cos will be positive, sin will be negative. So cos B minus, comma minus sin B. Okay. So now once you know this, you know that from circle rule, okay, if any two radius, okay, with the same angle, okay, they make same chord length. Okay, suppose if I take these 2 points, 1, comma 0 and cos A plus B, comma sin A plus B. If I take these 2 points, these two are, okay, this line, this chord is of length equal to, this chord length is equal to another chord which is from cos A sin A to cos B minus sin B. Why? These two also subtended by A plus B angle. These two also, okay, absolute value of this angle here is A plus B. Okay, both are subtended by A plus B angle, which means this chord length will be same. This chord length will be same. So just a distance between uh, these 2 points. Okay, 1 comma 0, cos a plus b comma sin a plus b is equal to distance between cos a sin a and cos b minus sin b. Okay, so just apply the distance formula. Of course, you can apply remove the square root. Okay, because both sides square root can be cancelled. Okay, if you simplify this, what you will get is cos a plus b equal to cos a cos b minus sin a sin b. This is the proof of this one. Excuse me. Okay, so this is a very useful equation of trigonometry or formula of trigonometry, compound angles. Based on this, we can build so many others. Okay, once you know the main one, we can build so many other things. You should remember these formulae also. Cos a minus b will be, this is very simple. You put just in place of b, in place of b minus b. Okay, then cos minus b is cos b, we know it, but sin minus b will be minus sin b. So this minus sign cos a plus b has a minus sign here, which will become plus here. Okay. Similarly, sin a plus b. Okay, the hint to solve this one is very easy. Proof. I'll just give you a hint. Sin a plus b is nothing but cos of 90 minus a plus b. Okay, this I will rewrite it as cos 90 minus a minus b. Now this is cos x minus y. So I substitute this formula. Okay, if I substitute this formula, then I will get this sin a cos b plus cos a sin b. Okay, this formula I will get. Okay, so sin a minus b will be sin a cos b minus cos a sin b. Okay, just be careful with the signs. Okay, that's the most important thing. And how do you remember so many formulae? See, tan x plus y is this value, tan x plus tan y divided by 1 minus tan x tan y. Okay, tan x minus 1 is this one. Okay, remember positive is only on the positive on the numerator, negative on the numerator. Okay, denominator is opposite. Cot x is this value. Okay, how do you remember so many formulae? It is very easy. You just keep practicing, and best way is do the proof once yourself. Okay, do the proof yourself once, then you will know easily by remembering the top one and three. If you remember, you can get all other things very easily. Okay, and more formula here. Okay, cos 2a, which is cos a plus b, right? Cos a plus a, which is cos square a minus sin square a, or 2 cos square a minus 1, or you can say 1 minus 2 sin square a, or you can also say 1 minus tan square a by 1 plus tan square a. This is one of the very important formula in trigonometry. In any problem you see cos 2a coming, okay, try to replace with 2 cos square a minus 1 or 1 minus 2 sin square a. Most of the times, 90% of the times, you get the solution with this replacement. Okay, so this is very important. Okay, next, sin 2a is 2 sin a cos a, or you can call it 2 tan a by 1 plus tan square a. Okay, tan 2a is 2 tan a by 1 minus tan square a. Difference is very only the sign. Okay, sin 3a you can obviously very easily derive yourself. Okay, from sin 2a plus a you can derive yourself. No need to remember. Uh, just I'm giving you information. Okay, all these things will be used in your questions. Okay, and some more formulas. Okay, cos a plus cos b equal to 2 cos a plus b by 2 cos a minus b. Okay, how do you do? This is just I'm giving you a hint. Uh, let's define x such that x is equal to a plus b by 2 and y is a minus b by 2, okay, which implies a equal to x plus y, b equal to x minus y. Now I replace cos x plus y, cos x minus y, and I already given you cos a plus b, cos a minus b formula. You expand that, substitute, expand it, you will get this value. Okay, so similarly you take this hint and solve it yourself. Okay, once you prove all these equations, they will be in your mind easily, and then start using every time, start using in a problem. Okay, first a few times you may be referring back pages for the formula, but after some time those formulae will be in your mind forever. Okay, so don't worry about how to remember so many formulae. You will remember very easily. Just you need to do is once you do the proof and then start solving problems. Okay, refer back the formulae initially and then solve the problems. And as you solve many problems, okay, you should solve in hundreds of problems, right? then you will remember this formula. Okay. So all these are important. Okay. Okay. Next is exercise 3.3. Okay. There's a lot of problems, but most of them are straightforward. I don't want to explain. Okay. Pi by 6, pi by 3, pi by 4 values, you have it. Straightforward, you substitute, you will get values. Okay. Solve it yourself and then check the answer. Okay. All are same. Okay. How to get sine 75? 75, you can write it as 45 plus 30, right? So sine 30 plus 45 is nothing but sine 30 cos 45 cos 30 sine 45. Okay, you substitute values, you will get this. Okay, and then tan 15. Okay, tan 15 is this value. Okay, now this one is you have to prove actually. Okay, so this is in the form of which form? Sine x plus y, right? So you take this one as a and this as b. So it will become right cos a. This is the formula I'm using. Cos A cos B minus sin A sin B equal to cos A plus B. So this one will is equal to, okay, cos A plus B, right? So which is nothing but cos of pi by 4 minus x plus pi by 4 minus y, which is nothing but cos of pi by 2 minus x plus y, which is sin x plus y. Okay, so all are straightforward. You can solve them yourself. Okay, okay. Cos pi plus x is, it will go into third quadrant, so it is minus cos x. Okay. Sin pi minus x is, it is in second quadrant, so it is positive. Okay. And cos pi by 2 plus x is nothing but sin minus sin x. Okay. In this case, you are using two formulas. So I mentioned here what are the two formulas you are using: sin A plus sin B and sin A minus sin B. Okay. These two you will be using. And it is very easy to solve. Only thing is, okay, here you are applying the algebra. A square minus B square is A plus B into A minus B. Then these two you are applying this sin A plus sin B and sin A minus sin B. Okay. You will get the answer. And then sine 2 theta is nothing but 2 sine theta cos theta. This also you are applying. Okay. Same thing here, a plus b into a minus b, and then apply cos a plus cos b and cos a minus cos b. Okay. Okay. So you refer the formula initially. Okay. But over the time, as you practice, you will remember this formula very easily. Okay. So keep doing problems, but you need to do so many problems. Okay. Hundreds of problems you have to solve to remember this formula. Okay. They should just come into your mind just like that. Otherwise, you will waste your time. You don't get too much time in your competitive exams. Okay. So all are basic formula which I mentioned. Okay. Two, three formulas only are there. Most of them you will solve using those two, three formula only. Okay. So don't worry about remembering them. It is very easy. Okay. You pause the problem and then solve it yourself. Okay. Okay. These are all the problems in exercise 3.3. Solve it yourself. None of them are difficult. Okay. They're just because you are doing first time with the formula, trigonometric formula, you may have to refer them back. Okay. But over the time, you will remember. Okay. Let's do the miscellaneous exercise now. Okay, there are some interesting problems in this. Okay, most of them you apply the formula, but if there is anything interesting, we will discuss those things here. Okay, this is I am applying cos A plus cos B formula. Okay, and then you will get the answer RHS proof. Okay, so most of the times you remember you may not be given something to prove. They may ask you to what is the value of this one. Okay, okay, here cos A minus cos B. So I apply this formula here, and sin A plus sin B formula I apply here. Okay, with that I'll get the value easily. Okay, so these are all straightforward. I'm just skipping them. Okay, because we learned so many things, so many formula in the trigonometry. Let's do all these problems. Okay, so again, this is a straightforward applying formula. Yeah, another thing where you apply the formula. Okay. Eighth problem is they gave you tan x. Okay, and you need to find sin x by 2, cos x by 2, and tan x by 2, or any other x by 2 trigonometric ratio. How do you do this? First thing is you draw the right angle triangle, 4 by 3 is there. You will find the other side. Okay, hypotenuse you will find, which is 5. And then you get the value of cos x. Okay, this is very easy. Cos x, once you get it, actually, minus 3 by 5, depending on the quadrant, right? It is second quadrant. Once you know cos x, okay, then how do you go to x by 2? Cos 2x equal to 2 cos x minus 1. 2 cos square x minus 1, right? Same thing I am applying here. Cos x equal to 2 cos square x by 2 minus 1. With this I will get cos x by 2 value. Okay. And one thing you remember, here x is in quadrant 2. So x by 2 will be where? X by 2 will be in quadrant 1. Okay. So that means it will be positive. Okay, remember this one very well. What is the value of that x by 2 trigonometric ratio, positive or negative? Based on this quadrant information, x is in quadrant 2, so x by 2 will be in quadrant 1. Okay, so once you know that in quadrant 1 all are positive, so sin x by 2, tan x by 2 will get automatically. Okay, the same way you will solve the other problems here. 9. Okay, yeah, 10. Yeah. So these are all the NCRT book problems, complete chapter. Just pause the video and solve it yourself and cross-check the answer and see if you are done in the same method, correct method or not. Okay. Now let's do some trigonometric functions critical questions. These are the questions mainly collected from competitive exams, mainly from JEE mains and BITSAT. Okay. So let's do the first one. So S is defined as theta belongs to 2 to 0 to 2 pi, such that a to the power of 2 sin square theta plus a to the power of 2 cos square theta equal to 16. Then, what is the value of number of elements in set A plus the sigma of given expression? Okay. So, first look at the given problem. We need to find out number of elements in S. That is first thing. Okay. And we have to define theta. Okay. Because you need to substitute that theta value in this expression. Okay. So, what are the possible values of theta? For that, we need to solve this equation first. Correct? We need to solve this equation. Okay. So let's take 8 to the power of 2 sin square theta plus 8 to the power of 2 cos square theta equal to, I want to first convert into either sin or cos so that it's easy for me, right? So 2 to the power of 2 cos square theta, I'm converting it as 2 into 1 minus sin square theta. So I can rewrite this as 8 to the power of 2 sin square theta plus 8 square by 2 to the 2 sin square theta. Okay, which is equal to 16, which is given. Okay. So let's call 8 to the power of 2 sin square theta as k. Then the expression will become k plus 64 by k equal to 16. You get a quadratic equation. Okay, it is given here, quadratic equation. If you solve it, you will get k equal to 8. Okay, k equal to 8 means 8 to the power of 2 sin square theta equal to 8, or okay, or 2 sin square theta equal to 2. Sorry, 2 sin square theta equal to 1. Not 2. This is 1. Okay. That implies sin theta is equal to 1 by plus or minus 1 by root square root of 2. Okay. And plus or minus 1 by square root of 2 is defined at 4 points in 0 to 2 pi, right? For sin theta. Either 45, 135, 225 or 315. That is pi by 4, 3 pi by 4, 5 pi by 4 and 7 pi by 4. These are the 4 values possible. So number of elements in set S is 4, n of S is 4. And these are the theta values. Now these theta values you should substitute in the given expression. That's all. So take this given expression, substitute the 4 values. What you will get is minus 8. Okay, carefully do it. Minus 8. So given answer is number of elements in set S plus the expression, which is 4 minus 8, which is equal to minus 4. That's the answer. Okay. So now you understand the difference between class 12th or class 11th maths and JEE or other entrance exams. Entrance exams questions will go deeper and it will basically mix all of your mathematical topics. This has a trigonometry, this has quadratic equations, correct? So this has sigma summation rules. So many things are mixed into this. Okay, this is how the level of questions will come in a JEE. Okay, let's do the next. If sigma of k from 16 to 30 is cos of k pi by 2 plus a is equal to x. Okay, and sigma of k equal to 16 to 30 sine of k pi by 2 plus a equal to y. Then what is the x by y? So to find x by y, you need to first of all find the values of x and y. Okay, so let's do one of them first. Okay, so one thing you should remember in trigonometric equations, all the angles are repetitive over the uh, as the angle progresses, right? Every quadrant, the values will get repetition. Okay, and you may get plus or minus. Okay, but the values will be repetition. Sine 60 is same as uh, sine 120, correct? Same as sine 18, sine 210, right? So like that, all the angles will repeat basically. You will get plus or minus root 3 by 2 for 60 plus 90, then plus 90 plus 90, correct? So first let us check the values of this first 4 terms. Okay, first 4 terms are cos of 16 pi by 2 plus a plus cos of 17 pi by 2 plus a, 18 pi by 2 plus a, and 19 pi by 2 s a. Okay, so we know that 16 pi by 2, where it will go? 16 pi by 2 is actually 0, right? At the x-axis 0 side, it's same as 0. So obviously that is, you can consider that as 360 degrees or 0, which is, so cos of 16 pi by 2 plus a will become cos a. That's it, right? And cos of 17 pi by 2 plus a is y-axis. 17 pi by 2 is at the y-axis. So whenever you remember, when the function of a trigonometric function changes, when it is the angle is with summation with y-axis. So here it is 17 pi by 2 is with y-axis. Okay. So it will become, cos will become sine, and it is in the first quadrant. So it will become minus sine a. Okay. So cos a, and this is minus sine a, and cos of 18 pi by 2 plus a is 18 pi by 2 comes here. Okay, so this is also cos theta is negative here. All silver teacups, if you remember, this is also negative. So minus cos a, but cosine will not change into sine because it is uh, even multiple of pi by 2. Okay, and next is plus cos 19 pi by 2, which is again comes here y-axis, y-axis. So it will change the function into sine, and here cos is positive, right? Fourth quadrant cos is positive, so it will become plus sine a. So this is what we get for the first 4, and after that everything will repeat, right? Next you will get again from here, 20 pi by 2 is nothing but here, 21 pi by 2 is here, 22 here, 23 here. So it will just repeat, keep repeating. So this first 4 terms summation is 0, which means out of this 30 minus 16 plus 1, that is 15 terms, 12 terms will be zeros. Only the last 3 terms will remain. And what are the last 3 terms? Okay, they are cos a, minus sin a, minus cos a. The last term plus sin a will not be there in that. Correct? So this is what is remaining, which is nothing but minus sin a. Similarly, you take y value, that is sigma k equal to 16 to 30 sine k pi by 2 plus a. You will get same First four terms are 0 and last three terms will remain is sin A plus cos A minus sin A, that is cos A will remain. So x by y is nothing but minus tan A. Okay. Yeah, hope you understand this. Next. So let's learn some more information about graphs of the trigonometric functions. So this is how the sine and cos graph looks. Okay, they looks almost same, right? Exactly same. Only thing is there is a phase difference. Okay, at 0 sine is 0. Okay, at 0 sine is cos is 1. Okay, so they are basically uh, uh, complementary, right? The sine is 0, cos is 1, and where sine is 0 at pi by 2, at pi by 2 cos is 0. Okay, so this is the major difference between sine and cos theta. Otherwise they are same. The range is between -1 to 1. You can understand, right? -1 to 1 range is okay, and they are cyclical. Okay, and one more important thing you should remember is area under half cycle is 2 units. Half cycle means I meant to say this part. Okay, from 0 to pi, this area. Okay, this area under this is 2 units. Okay, this is very easy to find out actually. It's not complicated. Only thing is you should know integration. So right now, if you are not learnt integration, just see this. But when you after learning integration and when you come back for review of these chapters, you will understand this expression very easily. Okay, integration of sin x dx is nothing but minus cos x, and the limits are from 0 to pi, right? That's what I am. Integration under curve is area basically. Okay, so 0 to pi I am taking, and this is exactly definition. Okay, area under curve is integration from 0 to pi I want to calculate. That is nothing but minus cos x pi to 0, which is nothing but minus cos pi minus of minus cos 0, which is 1 plus 1, 2 units. Okay, so I hope you understand this. This graph you should remember very well. Okay. Yeah. Next is if sine and cosine are drawn together, actually, they look like this. You can clearly see there is a shift of pi by 2, correct? Pi by 2 shift, right? Pi by 2 to pi, 0 to pi by 2. There is a 90 degrees shift in both the curves. Okay. And one more thing you should observe is both the curves meet at what is this point? Both are same at 45 degrees, right? That is pi by 4. Okay, pi by 4 they are same, and also this is 3 pi by 4. Okay, pi by 4 and 3 pi by 4. So if you are just interested, you can actually calculate what is the area under this yellow line and blue line. Okay, yellow line and blue line. How do you calculate? Same thing I told you, integration. Okay, the integration is pi by 4 to 3 pi by 4, and my expression is sin x minus cos x. I don't want completely under sin x in this, right? Sin x and minus cos x. If I remove cos x from this, what I will get is this area between sin x and cos x from pi by 4 to 3 pi by 4, which is nothing but if I expand, I'll get this value. Okay, minus cos x minus sin x or the limits pi by 4 and 3 pi by 4. If I apply it, I'll get square root of 2. This is the area between sin x and cos x points. Okay. So remember this. This is very easy to calculate. You don't remember the end value, but easy to calculate. Okay. And this is how the tan and cot graphs looks like. And as you know, tan is not defined for plus or minus pi by 2, plus or minus 3 pi by 2, and so on. Okay, they are not defined. So graph looks like this, and cot is looks like this, exactly a mirror image basically. And cot is not defined for 0, plus or minus pi, plus or minus 2 pi. Okay, and yeah, yeah. Let's do another problem. Number of solutions of equation 1 plus sine to the power of 4 equal to cos square 3x, where x belongs to minus 5 pi by 2 to 5 pi by 2. Okay. So one thing is first convert everything into all sine and cos into convert equations. Okay. All into all either sine theta or all cos theta. How do we do that? Very simple. Cos square 3x, we can write it as 1 minus sine square 3x. Okay. Now I got everything into in terms of sine. Okay. So that is sine power 4 plus sine square 3x equal to 0. Okay. Now we know the ranges of sine power 4 and sine power 3x. Okay, both are between 0 and 1 because they are square. They are not from -1 to 1. They are square and to the power of 4. So the range will be only positive values. Correct? So we know these two are positive. So when this expression will become true, when sine power 4x and sine square 3x both become 0, only then this expression becomes 0. Otherwise, it has some value. Correct? So which means either sine x equal to 0 or sine 3x equal to 0. Okay? This is the only solution possible. And when that solution is possible for sin x equal to 0, a range of x within this minus 5 pi by 2 and 5 pi by 2 is you have 5 values. That is 0 plus or minus pi plus or minus 2 pi. Okay, these are the values. And for sin 3x equal to 0, x will between these values. Okay, you will get extra two values plus or minus pi by 3 and plus or minus 2 pi by 3 you will get. But what we are looking is the value of x which can satisfy this complete equation, right? So we are looking at intersection. Okay, number of elements in A intersection B. That is only 0 plus or minus pi and plus or minus 2 pi, which is 5 values. Number of elements in A intersection B is 5. That is the answer. Okay, next. Yeah, now let's see the trigonometric graphs again, secant and cosecant. Okay, they look something like this. Okay, the graphs are looks like this. If you clearly see again, there is just a shift of 90 degrees. There is no other difference, and both secant x is not defined for pi by 2 plus or minus pi by 2 plus or minus 3 pi by 2 and all. Okay, you can see at pi by 2 minus pi by 2 it is not defined. Pi by 2 it's not defined. Okay, this curve will never meet at pi by 2. Okay, 3 pi by 2 etc. Same way, cosecant x is not defined for 0, pi, and if you take pi, okay, this graph will never meet this pi line, this vertical line. Okay, not defined for those values. Okay, next. Yeah. Let S equal to theta belongs to 0 to 90, pi by 2 that is, such that sigma m equal to 1 to 9 secant of this expression. Okay, look at the expression secant of theta plus m minus 1 pi by 6 into secant of theta plus m pi by 6 equal to minus 8 by square root of 3. And there are 4 options given. Only thing is first we need to find out the theta values. Okay, then we can tell the answer. Okay. So yeah, this one is also easy. Let's first simplify. Let's call A equal to theta plus m minus 1 pi by 6, B equal to theta plus m pi by 6. If I subtract B minus A, I get pi by 6. Correct? B minus A if I subtract, only difference is pi by 6. This minus pi by 6 will become minus of minus, which is plus pi by 6. Okay. Once you know this, you can simplify it very easily. So this sigma value will become nothing but sigma m equal to 1 to 9 secant A secant B, okay, which is equal to, I'll rewrite it as 1 by cos A cos B. Correct? So the 1 I am writing it as 2 sin B minus A. Why? Sin B minus A is pi by 6. Pi by 6 is 30. So sin 30 degrees is 1 by 2 into 2, which is 1. Okay. So I wrote it as 2 sin B minus A. Now I can expand it easily. Okay, sin b minus a, I'm expanding it. Okay, 2 I took it outside the sigma value, and the sin b minus a is nothing but sin b cos a minus sin a cos b divided by cos a cos b, which is equal to 2 times sigma of tan b minus tan a. Okay, now let's see why we actually came to this value. Okay, at any point when sigma things are given, first always try to simplify the equation into some addition or subtractions. That way so many terms gets cancelled. Okay, so many terms gets cancelled by themselves. You will be left with 1 or 2 or nothing. Sometimes directly you'll get the answer 0. So here also you have tan b minus tan a, and we know that tan b and tan a there is only minus pi by 6. So every time you apply the sigma at every sigma, basically every loop you get cancellations. Okay, so you are left with finally, okay, finally you are left with if I substitute these values, what I am left with is tan of 2 tan of, sorry, okay, 2 times, which is there already, I am left with tan of 9 plus theta plus 9 pi by 6 minus tan theta. These are the only two terms. Last term and first term I'll be left with. Rest all gets cancelled. Okay, you can expand and see. This is equal to minus 8 divided by square root of 3. Right? This is what is given. Now let's see how to solve this problem. Okay. So tan of theta plus 9 pi by 6 is nothing but minus cot theta. So where this comes actually? 9 pi by 6 is nothing but 9 pi by 6 is nothing but if I divide it with 3, 3 pi by 2. 3 pi by 2 is third quadrant, correct? So 3 pi by 2 is nothing but third quadrant, right? So tan of theta plus 3 pi by 2, 3 pi by 2 plus theta is nothing but minus cot theta because you are going into fourth quadrant. 3 pi by 2 plus theta. You are into fourth quadrant tan is negative. So minus cot theta minus sin theta equal to minus 4 divided by square root of 3. Okay. Now, okay, this is the expression which we have last. Okay, this I am writing it as 1 by sin theta cos theta. Why? Because if I simplify here, cos theta by sin theta plus sin theta by cos theta, take the LCM sin theta cos theta, and I'll get sin square theta plus cos square theta, which is 1. So this is equal to 1. So I will take 1, 2 here. Okay. So this is in the form of sin 2 theta, right? So sin 2 theta is nothing but root 3 by 2. Theta belongs to, what is the value given? Theta belongs to 0 to pi by 2, correct? So now you define the values. How many values are possible? Okay, sin 2 theta equal to root 3 by 2. That is the actual expression which we need to solve. Okay, 2 theta equal to pi by 3 and 2 pi by 3. Both values, at this both values, sin 2 theta is 3 pi by 2. Okay, so which means theta is equal to pi by 3 comma pi by 6. These two values are possible. So set S will have two values, pi by 3 and pi by 6. Okay, now this is the S actually. The question in the question they have given options actually. The four options are here. S is only pi by 2, B S is 2 pi by 3, or sigma theta belongs to S theta, that is sum of all angles equal to pi by 2, sum of all angles equal to 3 pi by 4. So if I sum up pi by 3 plus pi by 6, I get pi by 2. So answer is C. Okay. Hope you understand this. Okay. So the trick is first thing, all products in sigma, all products convert into additions or subtractions. Okay. That way, most of the cyclical terms gets cancelled. You are left with only few terms, and that is easy to solve the problem. Okay. Next. Number of values of x belongs to pi by 4 to 7 pi by 4 such that 14 secant square x minus 2 sin square x equal to 21 minus 4 cos square x. Okay. Okay. And this equation should hold. Okay. And then what is the values of x? That's the question. Okay. So sin square x, let's take sin square x equal to k. So expression is very simple. 14 by k minus 2k equal to 21 minus 1 minus k, which is cos square x. I am writing it as 1 minus sin square x. Cos square x I am writing it as 1 minus sin square x. That is 1 minus k. Okay. If I simplify, I get a quadratic equation. Solve it. Okay. I get 2k plus 7 into 3k minus 2 equal to 0. Okay, 2k plus 7 into 3k minus 7 equal to 0, or k is equal to, I get two values, minus 7 by 2 and 2 by 3. And clearly, sin square x equal to 2 by 3 is the only solution because minus 7 by 2 means it is minus 3.5, which is out of range for sin square x. Sin square x is only positive 0 to 1. That's it, right? So it is minus 3.5, which is not possible. So you can ignore it. So sin square x is 2 by 3. This is the only solution we have, right? Now, what is the angle? What is the possible angles of x in the range pi by 4 to 7 pi by 4? Okay. Now, let's see. This is the sin x equal to plus or minus square root of 2 by 3. Okay. We don't know the values of the square root of 2 by 3 trigonometric ratio. So we need to assume how many number of solutions are possible now. Okay. So let's understand this. We know that the sin 45 is, that is pi by 4 is 1 by root 2. Okay, and this root square root of 2 by 3 is greater than 1 by root 2, which means x is greater than 45. Okay, because sine is incremental function, right? Incremental cyclical basically. Okay, so x is greater than 45. This is one thing. Okay, and if you apply minus sign, basically then minus root 2 by 3 is less than minus 1 by root 2, which means x is less than 45 in this case. So each quadrant will check it. This is the 4 quadrants. Okay. Starts with 0 here, 90, 180, 270, and 360 or 0 back basically. So where is pi by 4 to 7 pi by 4 comes into? Pi by 4 is somewhere here, 7 pi by 4 here, and the angles of x we are looking in this area. Okay, in this range, we are looking for x values. How many x values are possible? Where you have plus or minus square root of 2 by 3. Okay, it is possible in every quadrant. Okay, right? Because it comes somewhere here. Okay, for because it is greater than 1 by root 2. Here you don't need to worry. There is nothing to compare. You have root 2 by 3 because sign in second quadrant is positive. Here it will be minus root 2 by 2. Third quadrant. Fourth quadrant it also minus root 2 by 3, which is less than minus 1 by root 2. So you will get 4 values. So number of possible solutions of x is 4. That is the answer. Okay. Yeah, hope you understand this problem. In trigonometry, it is very important what are the ranges, what are the domain of the angles basically. Okay. What are the possible angles where solution can be obtained. Okay. So yeah, that's all the questions I covered in the trigonometry, but trigonometry is a very, very vast chapter, as I said. It is part of every other integration and differentiation is zero without trigonometry. Okay. And most of the quadratic equation questions will be asked with the trigonometry. Okay. And many of the geometry questions also with the trigonometry. Okay. So it is very important. I will definitely come up with more questions, more critical question videos as well as charts. Charts already I started for trigonometry. You can start looking at daily question. Okay. And this is one chapter. If you do it well, it will help you in physics. It will help you in other maths. Okay. So thank you.